Hello everyone. In this video, we are going to start with the binary search algorithm. So, binary search algorithm is defined as a searching algorithm which is used in the sorted array. So, if your elements are sorted, then only we can apply the binary search. Otherwise, we will use linear search algorithm. So, how this algorithm will work? Now, the binary search algorithm is based on the divide and conquer strategy. Meaning is the list or elements of the array we are going to divide into two parts. Okay, and this thing we will do repeatedly. So it's written that repeatedly dividing the search interval in half. Every time we will do this thing until we will not find the element. So what could be the advantage of this? The advantage of binary search is when given array is sorted, then it gives the time complexity of log n, which is less than the peak of n. Okay, so which is the complexity of linear search algorithm? So this binary search algorithm will give you less time complexity. It means it will give you the element which is searching can be fast. So let's take one example to understand the binary search. Let's suppose we have been given some elements. These are the 10 elements we have been given. Now, since we have to divide the element into half, how I will going to divide the list? So I will divide the list according to the index. So the index of these elements are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you want to find the middle element, you will find divide 0 plus 9 by 2. If you do this, you will get 4.5. Now 4.5, you may write as it is the 4. So we are not rounding off. It is actually the integer value we are writing, because the mid value we are defining as a integer value in the program, and this value will automatically be converted to 4. According to this, our middle element is this way. So in this way, we are dividing the elements into two parts. Now why we are dividing? See, if you want to search anything, let's suppose you are searching for 20. If you are searching for 20, then you will search for middle element first. You search for 20, then you will search for middle element first. Now, if you compare the middle element and middle element is 8, you can see this 20 is greater than 8. So obviously, from here you can say that the element 20 will be present in the right side, because the element 20 is bigger than 8. So it could not be present in the left of the array, or left of the 8. So what we will do now? So again we will divide. So this thing we are going to repeat multiple times. Okay. So what I will do now? I will consider this value as a lowest value, and this value is the highest value. Okay. So how do you find the mid element? Mid element you find it is by low plus high by 2. The low value is 5, high value is 9. According to that, you will get middle value as a 7. In the algorithm, every time we are going to find the middle. Now, what I will do? The middle element I will check. The middle element, if you check, you will find that it is 15. 15, again, this 20 is greater than 15. 20 is greater than 15 means again the 20 will be present on the right side of the 15. So I can ignore this list now, and I will focus on this new list. Again, what I will do? Again, I will change my index. Low index I will change. High index will remain same. Again, I will do low plus high by 2. Again, if you do low plus high by 2, you will get 8 plus 9 by 2, that is 17 by 2. And 17 by 2, if you solve it, you get 8.5. It will be considered as a 8. Means the next element you are searching is this one. This index I'm getting. So that's why I'm comparing with this. So 20, again I'm comparing. You can see again it is bigger than the 18. So I will search on the right hand side. Now, your low and high will be same. So if you calculate low plus high by 2, you will get 9 only. And if you search 20, you will find that 20 is equal to 20 and element found. So in order to search 20, how many comparisons are you making? Total 4 comparisons you are making in the binary search. Now consider a linear search. To linear search, then you will compare 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 times you will compare and then you are getting the 20. And in the binary search, you can see in the 4 times only we are getting the answers. Means the time taken by binary search will be very, very less for big number of array. That is equal to log n. Now, how this algorithm we are going to write stepwise. Okay, so now we will discuss the language form of binary search. Okay, so that we are going to discuss two algorithms of binary search. One is in form of pseudocode and another one is in form of just in the English language form. So what we have done? We have divided the search space and array into two halves by finding the middle index. That is mid we are finding. Then we are comparing the middle element of the search space with the key. Key means the element we want to search. Now, if the key is found, at the middle element, mean the process is terminated. Okay, that could be our best case we can see. If the key is found means we are finding the element at the first place only, the middle element only. That could be your best case. But if we don't find, then what we will do? If the key is not found at the middle element, choose which half we will use as a next search space. Means whether we will search in left side or right side. Now you know if the key is smaller, the element which is we are searching is smaller than the middle element, then we will search left side. And if the key is larger than the middle element, then that we will search for right side of the array. So this process we will continue until the key is found or the total search space is exhausted. Okay. So this is the binary search algorithm. Now you already understood how we are going to write the pseudocode of that. Here, the binary search is the name of the algorithm. Or function we can say it's the binary search where we have array, where we have lower bound, upper bound of the array, and the value which we want to search. Step number 1 will be we will set the beginning or ending value, or we can say low or high value. So lower bound is your beginning and upper bound is your ending. And one more thing we are going to set, that is POS is equal to -1. Step number 2. Repeat step number 3 and 4 while beginning is less than is equal to 20. What is step number 3 and 4? Step number 3 is finding the middle element, which we can find by beginning plus ending divided by 2. Now what is step 4? In step 4, we are checking for the middle element. How to check? A of mid is equal to value, then we can say that our POS is equal to mid, means that index is the position. And that position I want to print, means element is found at this particular index that I will print. And after that, I can go to step number 6, that is exit. Else if the middle element or A of mid is greater than value, the middle element is greater, means I have to change the index of the end. I have to change the index of and to mid -1. Why? Why we are changing that? Let's suppose we have 0 here and we have 8 here. Okay. Now, you know that this is some element and this element is bigger than the element we are searching. Then we will search left side. You search left side means your beginning index will not change, but your ending index will change. That will become mid minus 1 because this was your middle element. That's why here I'm writing mid minus. Else, if it is less than big is equal to mid plus 1, we are going to say. Step number 5. If position is equal to minus 1, means element not found. If position we are not changing or we are not able to change the position value, that is minus 1. Okay. It means element not found. So we will say that value is not present in the array. And finally we will exit. So this was the binary search algorithm. For writing the program, we can use either iterative method or we can use recursive method. Both methods are very identical, but both have different methodology. The algorithm is same only. If you use iterative method, then this thing we are going to repeat in the loop. So what we are going to repeat in the loop? First step, mid is equal to low plus high by 2. And then we are checking if x is equal to array of mid, then return the position of that index, that is mid index. Else if we will check for value if it is greater than or less than. If it is greater than, we'll change this index. If it is less than, then we will change high is equal to mid minus 1. This is the iterative method. This is very easy, but what about recursive method? What we will do in the recursive method? The recursive method, obviously, recursion we are going to apply. Recursion means when we will function call itself. The same function will call itself, then the method is will be called recursive. So let's suppose we have one function binary search. Now, if we are using recursive method means obviously we will be calling function inside that function also. So what we are doing? If low is greater than high, then we will return false. Then we can stop. Else, what I will do? I will calculate the middle value and middle value I will check first. If that is equal to, then I will give the answer that is return mid. Else, if x is greater than array of mid, then we will call this function again with the different value. What the different value? Array and x is same only. But this value, this low value will become now mid plus 1 because we are now searching on the right hand side. Right hand side of the mid is mid plus 1. That's why the low value will become mid plus 1, high value will become same only. Okay. Else, what will happen? If you search left hand side, then this value, this is mid minus 1. So this value will change. Low value I will not change. Okay, this low value is same only. The high value I will set to mid minus 1 and then again I will call the function here. So now this time here instead of high it will be called mid minus 1. Again it will run same thing and it will be repeated until the element not found. Or this condition is satisfied, then we will say that element not found. Now we will understand the binary search complexity. Here also the best case complexity is theta of 1. Why? Because if you search for any element and you find the middle element as your element, then we can stop the process without running the loop or without calling the multiple functions. That's why the best case is theta of 1. The worst case and average case is log n. How it is log n? So let's understand the scenario. Let's suppose we have n elements. We have total n elements. what we are doing in the binary search. In the binary search, we are finding the middle element. It means we are dividing the list into two parts, n by 2, n by 2. Now you know that in binary search, one side element will be there. So I can ignore any one list. So let's suppose I am ignoring this list. What I will do? Again, I will find the middle element. To find middle element means again you are dividing the list into two parts. You are dividing the list into two parts means now we have n by 4 number of elements. So this process will be repeated again. Again you divide the list. Again it will become n by 8, n by 8. So in this way, we will divide the list until the solution is not found. Let's suppose before reaching the solution or before finding the element, we are running this loop k times. Why I have written 2 raised to the power k here? The thing is, if we are dividing one time, means here n by 2 raised to the power 1. If we divide the list two times, then it will become n by 2 raised to the power 2. If we divide the list into three times, then it will become n by 2 raised to the power 3. In the same way, if we repeat it k times, the list will become n by 2 raised to the power k. And finally, this list will become equal to the 1. Means only one element will be left in the end. In the end, in the worst case, last element will be left. So n by 2 raised to the power k is equal to 1. Now just we have to solve this equation and we will get our complexity. If you solve this, you will multiply 2 raised to the power k with the 1. We will have to take log both sides. Okay, we are taking log both sides. Then this will become log 2 raised to the power k. According to the properties of log, this k can come this side. Now the log 2 and the base 2 we are taking here. Okay, base 2. So log 2 by log 2 will become 1. The value of k will be finally log n. The value is k is equal to log n means this is your complexity. Why? Because this we are running k times. If this process we are repeating k times means this is your complexity. So k, the value of k is log n. That's why in the worst case, the complexity will be log n. So in the average case also we will have log n. If you write log n by 2 also, then it doesn't matter. It will remain log n only. So this is all about the binary search algorithm.